Hi fellas, this is Chemaddicts again with the solution. Welcome back to another video tutorial. Well fellas, now we're gonna solve this question for a given. We're gonna solve this question. In this question, we're gonna find the half-life, not love, half-life for a first-order gaseous reaction. Okay, so let's read the question at first. For a given initial reactant pressure, the half-life for a first-order gaseous reaction was found to be 30 minutes. Okay. So if the experiment were repeated at half the initial reactant pressure, the half-life would be this, 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 or this. So let's see. So they have asked us to find the half-life for this reaction. Okay. So since if we look closer, we can see that here they didn't talk about rate. Okay, so rate is not involved. Rate is not given. So the information about the rate is not given over here. Okay, so there is no information about rates. Okay, so only they have mentioned about half-life, finding the half-life, and this is the first order gaseous reaction. This is the only thing that they have included. Okay, they have given. So here, since the rate is not given here, okay, so we can find half-life by another way using an equation. Okay, so since we can see that this is the first order reaction. Okay, so for first order reaction reaction for first order reaction, the half-life is equals to simply ln 2, this is ln 2 divided by k. Okay, so in here we can say that uh, we know that for a first order reaction, rate constant, this is the rate constant. Okay, where k is rate constant, where k is equals to rate constant. Since k is the rate constant, so we all know that for first order reaction, k is constant. This is constant. Since this is constant, so half-life would be constant. So if the experiment were repeated at half the initial reactant pressure, the half-life would be. So we can see here that half-life is not dependent. Half-life is independent. It is completely independent. Okay. So since half-life is completely independent, it won't depend on other factors. Okay, whether we will increase the initial pressure or anything, concentration, blah blah blah, whatever. So the half-life won't be affected by any factor since the half-life is independent. Okay, see here value of ln 2 is constant, here the k is constant. K is constant, that's because this is the first order reaction, so the half-life would be same regardless of any factor. Okay, so here the half-life, the previous half-life was 30 minutes, here the half-life would be 30 minutes, so the answer should be 30 minutes. So here are some points that you need to know, that half-life is constant for first order reaction. Okay, and k, that is the rate constant. Okay, rate constant is also rate constant is also constant for first order reaction. So here are two things that we need to know, that half-life is constant for first order reaction, and K is also constant for first order reaction. Okay, so B is the answer. So I hope that fellows you have understood, we have understood the question as well as the answer. So if not, please let me know in the comment section. Okay, so let me know in the comment section. I am always there to help you out. Okay, so let's move on to the next question. So in this question, they have said, the question said, to determine the activation energy for a reaction, the variation of reaction rate with temperature is investigated. Okay. The rate constant K for the reaction is related to the absolute temperature. So the rate constant, so the rate is related to the absolute temperature T. So this is the absolute temperature given, and this is the rate constant K by the expression. Okay, so this is the equation given. Here is one thing that we need to know, that this is the Arrhenius equation. Arrhenius equation. So this is the Arrhenius equation. Okay, now we're gonna deal with Arrhenius equation. Okay, so if we compare this equation, well, at first let us see one thing, that this equation is similar to another equation, that is the equation for a straight line, that is y is equals to mx plus c. Okay, so if we compare this equation with a straight line, we will get something similar, something familiar. Okay, so then we will get something like this. So if we compare, then the value for y is equals to ln k, and m is minus e by r. Okay, and the x is 1 by t. So this is the x and this is constant. So here y is equals to ln k, and x equals to 1 by t, and m uh, which is minus e by ea by r. Okay, this thing is gradient. Since this is the equation for the straight line, so m is the gradient, so this whole thing should be the gradient. Okay, so here is one thing that we need to know, that we have introduced ln on both sides in Arrhenius equation to make it a straight line. Okay, so here, since this graph might not be straight line, if we plot it like uh, something like this, something else, if we plot something else. Okay, okay, if we plot something else, then the graph wouldn't be the straight line. So we have introduced ln on both sides, okay, in Arrhenius equation to make it a straight line. So that's why this equation is family, this equation corresponds to the straight line. So that's why we have introduced ln on both sides. Okay, so the actual equation is k is equals to ae to the power minus ea by rt. So that's the basic equation. Okay, let me check whether my equation is correct or not. I'm checking. Well, it's correct. So this was the original equation for Arrhenius equation. This is the original Arrhenius equation. This is 100% genuine Arrhenius equation. Just kidding. So in order to make it a straight line, okay, this is not a straight line. This is a curve, exponential. We will get exponential curve from this equation if we plot a graph. So in order to make it a straight line, we have introduced ln we have introduced ln k on both sides. Okay, so that is how we gonna get the straight line. So since this corresponds to the equation of the straight line, so is this should be a straight line if we plot ln k against 1 by t graph. Okay, so in here let us write something. Okay, so this is the Arrhenius equation. So in here where k is equals to rate constant, a is equals to frequency factor, okay, frequency factor, a is equals to frequency factor, then ea equals to activation energy. We all know that this is activation energy, not allergy, energy, sorry. Okay, just kidding. Then this r is molar gas constant, and T here, T is equals to temperature in Kelvin. Okay, so this is the demonstration of the Arrhenius equation. So this is the Arrhenius equation where k is equals to a e to the power minus ea by rt. Okay, so where k is the rate constant, a is the frequency factor, ea is equals to activation energy, r is equals to molar gas constant, and T is equals to temperature in Kelvin. Okay, so in here let us answer this question. The activation energy for the reaction could be obtained by plotting a graph of which one? So vertical axis, we all know that the vertical axis is y-axis and horizontal axis is x-axis. So in here, if we compare this equation with this straight line, okay, so this is equals to y is equals to mx plus c. Okay, so this is not square, this is arrow, my mistake. So in the y-axis this should be ln k, y-axis should be ln k, and on the x-axis this should be 1 by t. Alright, so here let us match this one with these options. So if we match, this thing comes up. So here D is the answer, okay, to this question. So vertical axis is y and horizontal axis is x, then this should be the answer. So fellas, I hope that you have understood the question as well as the answer. So if not, please let me know in the comment section. So if not, let me know which part you don't understand and which concept you are not clear. Okay, so fellas, that's the end of this tutorial. So I'll put the link at the end of this video tutorial of previous episode. So if you have missed them, you may watch them out. So signing out, fellas. Best of luck for your exam and peace with chemistry.